Hello and welcome to another video tutorial on how to use C++. Today we are going to cover the topic of control structures, and as usual we are going to start C++ or start Visual Studio and create a new project here. So Win32 in Visual C++, we have to select a name for this, so this time number 3, control structures. Okay, so next, and then we are going to start with an empty project, and here in the source data we have to add a new element, and this element is going to be our main. So click on add, and now we can start coding as usual. So first we are going to include our IO stream. So now just include IO stream is the first thing. The next thing is our standard namespace using namespace std, and also our main method, which is covered here. Now, what are control structures? Well, in short, these are instructions in order to control the course of actions that we have programmed. So for example, let's look at the if condition that we already used in the last tutorial, but now in detail. And for this, I'm going to create a new variable, a new constant variable. So that's why I'm typing in const double pi equals 3.1415 and so on. And because I'm creating this outside of the actual main method there, this is called a global variable. So no matter from where I want to access this variable, it will be always this number, and that's why it's called global variable, and I can access it from everywhere. So now if, and now there is the condition, and in our case, for example, if pi is greater than 3.15, so in this condition is either true or false, and if it's true, then the next block of instructions is going to be executed. And in our case, this instruction is just an output, so cout and please check pi. So we add an end line here, and we have to set a return value, and now we can run this. So let's see what happens. Exactly nothing. So no output, no special output, because pi is correct. But if we change now pi to 3.15, then we see that there's the output, please check pi. And this is because pi, which is checked here, is now greater than 3.15 and therefore is wrong. And so this expression becomes true, and then the output follows. So this is a relational operator, but we also have many more. So for example, greater and smaller than are relational operators, but I can show you more. So for this, I'll set pi back to 3.14, and let's try the smaller than operator. So in this expression now, it is checked if pi is smaller than 3.15, which is true because I set pi back to 3.14. So, and if we run this, then you see the output appears here, which is not to be understood as an order, but more as a check that the smaller than operator also works. This can be changed to, let's say, block of instructions, of course, to not get confused. So let's just change the output here and check, and now the output is block of instructions 1. Okay, so another comparison operator is the is equal operator. But you have to be careful because it is not used with one equal sign, because this would be the assignment operator just as above, so where a value is assigned to a variable. So but you have to add another equal symbol, so 2 of them, to check if pi is equal 3.15. And the output is nothing because pi is not equal 3.15 because it is 3.15 and so on. So, but if we change our pi to exactly 3.15, then of course the output is to be seen. Okay, pi back to normal, and the next operator is the is not equal operator, which is indicated by an exclamation mark followed by an equal sign. So, and if we run this, then you see the block of instructions is in the output because we have the check here whether pi is not equal 3.15, which is true, and therefore we get the output. Then we have the greater or equal operators. So let's put this here, and just to show you, I'll copy the value from above. And if we run this now, then you see that there is an output because the expression is set to true because it is equal and therefore also greater or equal. The same thing is for smaller or equal. There's also an output here, and just to complete this, if we put a smaller than operator here, then there's no output because the expression is false. The next thing I want to show you are logical operators, because with those we can combine the relational operators, so we can check two things at once. And for this we are going to define a new variable, a equals 5, and then add this one to this condition. So first of all we are going to set to check if pi is smaller than 3.15, and then we can check our second condition by adding the double and symbol to add the second one, and the second condition, so this is the first one, the second could be a is equal 5. So 2 equal signs, and then we have two conditions and both should be true, and then if both are true, then the output is here. If we check if a is equal 4, which is not, then we see that no output is created because one of the conditions is false, and this means we get no output. To change this, we can exchange the logical AND to logical OR. This is done by the two vertical lines, and with those, either of those conditions can be true so that we can get an output. And in this case, the expression that is true is the first one, so pi is smaller than 3.15, and the other one is false, but that doesn't matter because we have the logical OR. And just to complete this, we can also set a2 is equal 5 to see that we still get an output, because we just need one expression to be true, but both is also just fine. If we now check if pi is smaller than 3.14 and whether a equals 4, then both of these expressions are false, and the whole expression is also false. So because neither of those is true, so OR is also false. And you see we don't get an output, which means the if condition is not completed. Next, we have a logical operator that checks for falsehood. So if I check if a equals 5, then the expression would be true. We can check this by running our program, and you see that there's an output. But to falsify this whole expression, we can set an exclamation mark in front. Then the expression is if not a equals 5. So the whole expression will be set to false, and then there's no output. So let's reset our conditions, our inquiries, to whether pi is greater than 3.15, so that our pi should be checked, and then also reset our output to the instruction please check pi. And the next thing I want to show you is an if-else inquiry, so that we get an either-or decision in our code, and then we have two conditional blocks of instructions. And to do this, we just add another block of instruction, which is the else instruction here. Just like the if condition, we also add curly brackets and an output, which is gonna be saying that pi is not too large, so it's probably okay. So like this, and then end line. And we run this to see what the output is gonna be. And you see it is that pi is not too large. So the program skipped the if condition because pi is not greater than 3.15 and straight goes to the else condition, and then we have this output instead of the other one. To see that this works, we can set pi to a wrong number, which is too large. So if we run this now, then we get the output please check pi. And we can continue this method by just adding another condition here. So first we are going to change the output here to pi is too large, because pi then is greater than 3.15. We have another possibility that pi is plausible. So we're going to put this here. And we can add another condition, which is called else if. So we just add another instruction block with else if and also with curly brackets. And the condition for this is else if pi is smaller than 3.14. Then in curly brackets we can set the output to pi is too small. So if pi is not greater than 3.15, it might be smaller than 3.14, and we get this output. So pi is too small. And in all other cases, we get pi is plausible. So let's test this. I'm gonna set pi to 3.13 something, so this is too small, and we should get the output pi is too small, and we do get it. We can set pi to 3.15, and we get the output pi is too large. And if I reset pi to 3.14, we get the output pi is plausible. And we could expand this structure with else-ifs for as many as we like, but of course at a certain point it becomes meaningless. So that's it for the if control structure. Let's comment this all out and go to the next one. The next control structure is the switch statement. It compares an expression with different constants and then goes in a branch. For this we use the keyword switch, and here we type in on switch on the expression we want to check, which is A, write the A from above, and then we go to different cases, and for those I type in case 1, and in case 1 I want to have the output case 1. Type an end line here. Then we create a second case, case 2, but don't forget the break at the end of each case, so break and then case 2. And here I want to have the output case 2 and break, of course. And if neither of the two cases matches, then we get to the default at the end, which is just a simple break. And we can also make an output that none of the cases matches, so the input doesn't match any case. And then we can also delete the break here. So now again we have our switch here with the variable A, and then the program compares A to 1 and checks if it is 1, then it goes to case 1, or if it is 2, then it goes to case 2, and in all other cases the output would be that the input is not matching any case. So let's test this with a 1, and we see that if we type in A is equal 1, then we get the answer case 1. If we type in a 2, then the output is case 2. And if we type in a 3, then we see that the output is that the input doesn't match any of our cases. So you see that the default here corresponds to the else condition that we had before, because in all the other cases then it goes to the default case. Okay, so let's comment this out. And we have now seen the if and switch control structure, which are both used for branching. What we want to look at next are loops. Many problems in programming can only be solved by repeated executions, and to execute a block of instructions multiple times, we simply use loops. And to look at this problem, we have a simple example for this. So we want to count until 10, and we can do it either in this way, so we type in cout for every number, so output 1 and then repeat until 10. So we have 1, 2, 3, 4, 5 and so on until 10, and then we could execute this, run the program, And we see that here are the numbers from 1 to 10. But this is very cumbersome, especially when we are not counting until 10, but let's say 1,000. A more elegant way it would be if we do this with a for loop. And to do this, we type in for followed by round brackets, and in these we need 3 arguments separated by a semicolon. So the first one is the counting variable, which counts until 10. And for this, we just type in integer, because this is an integer variable, and the name is I, and we assign the value 0 to it. So I equals 0. Next, we have our exit condition, which in this case is I is smaller than 10, because we want to count until I equals 10, so I smaller than 10. And the last one is our action, so what is taking place if the condition before is true. And this in this case is I++, which means I is incrementing. And then we have our output, which is just the counting, so we set it to the value of I is, and then I. Okay, so now what happens if we run the code? You see here that the numbers are incrementing from 0, and this is because we initialized I with the 0. And then there's the check if I is smaller than 10, which is true at this moment, so the instruction is being executed, so the output is being made, this one right here, and then after that I is being counted up, so set to 1, and then again I is checked if it is smaller than 10, and if it's true then there's the output, and after that another counting. So we have this until 9, and then if I is 9 then or 10, then the exit statement here becomes false. So if I is 10, it is not smaller than 10 anymore, and so then 9 is the last output, and the loop is left. So this is the for loop, and as you have seen, this is the way more elegant way to count until 10, or let's say 1,000, like this. And to really count from 1 to 1,000, we can initialize I with 1 and check if I is smaller than 1001. So you can see here that if we run this, then we really count it until 1000. Okay, that's it for the for loop. Let's comment this out and go to the next chapter, which is a while loop. So while loops are executed as long as a condition is true. And for while loops, we only need an exit condition. So we just type in while, and then in the round brackets, our exit condition, I is smaller than 10. And then, just as usual, we add our curly brackets with the output, just like in the for loop, we are putting the value of I is, and then the variable I. But now we still haven't initialized our I, so that's what we have to do before the while loop. So we are setting integer I equals 0. And now we can test our loop. But as you see here, this is an endless loop, because the value of I is always 0 because we have initialized it with 0, and nowhere is to be seen that we are incrementing I, so it will never reach 10 and always stay 0. That's why we have to add the increment, so I++ at the end of our while instruction, like this. And then if we run this, then you see the output as we wanted it, from 0 to 9. So that's it for while loops. I'll comment this out as well and hide it. And the last thing is a do-while loop. For this we are using the keyword do and then our curly brackets, and because it is a do-while loop, the while is also a parent, but at the end of the loop. So the condition is checked at the end of the loop, and the condition is, as usual, I is smaller than 10. And now we can just enter our loop with the output which we had before. So the value of I is, and then I, and we have initialized I already, so we can run this and see this is again an endless loop because we are not incrementing our I yet, but this can be added after the instruction here. So we have I++ after this, and then now our output looks correct. So the code goes through the do-while loop at least once, and then the condition is checked at the end, where in contrast with the while loop, there's potentially not one run-through. But in some cases, you want at least one cycle of the loop, so there you should use the do-while loop. And a possible error source in the do-while loop is the semicolon at the end. This is sometimes forgotten. So now we have got to know all the control structures, and first comment this out and then let's review. So at first we had the if condition where we could check conditions and then execute instructions accordingly. And a very similar control structure is the switch condition, which checks for constants and then branches into cases. Next we had our loops with the for loop, which had arguments here and the increment of our counting variable, and then our instruction. And we also had the while loop, which had the condition in the beginning and checking if it is false and doing the instruction as long as the condition is true. And in contrast to this, we had our do-while loop, which at least runs through once and then checks if the condition is true or not. So that's it for this time, and thank you for your attention.